Go. All right. So some questions from the prep for 1-7. Some of it was review from before, and it comes up here because we're adding together different parts of area, which relates to algebra in a way. So x squared literally is a square that is x by x. And so the x squared is the area, right? And so we can put together chunks of area. So for example, remember with the house, we said it was 50 feet by 40 feet with a little pop-out area. And then the backyard had a similar thing. It was like 130 by 115 with a little pop-out area on the side because the house had a pop-out area. So we had to add different pieces of area. So algebraically, what that works out to be, if you had 3 chunks of area, right, 3x squared, and then you have 2 more chunks of area, how many chunks of area do you have altogether? 5 of them. Yeah, because x squared is just a chunk of area. So altogether, I have 5 chunks of area. When we put together things like that algebraically or with area, this is called adding like terms. So all a term is just a piece of an addition problem. So this thing has 2 terms to it. Yeah. They happen to be alike, so I could simplify it.
Okay. Last night, I had known that one of those, like it was 3x squared plus 3x, and
yeah,
I tried to combine them.
So what if we try to do something like take 3x squared and add that to 5x's? Well, we got to pause and think about this for a minute. An x squared is a chunk of area. Okay? An x is a length I measure with a tape measure. It's like a piece of string. What happens if you add a floor tile to a piece of string? What do you get? You get a floor tile and a piece of string, right? You can't do anything with that. You can put them together and say, here's a floor tile and a piece of string, but you can't simplify it algebraically. So these guys are not alike. They're not like terms. So can I add them? Yeah, I just did right there. Can I simplify it? No, can't be simplified.
You can't add the 2x plus just the x?
No, they're just different things because literally they are an area and a piece of string. What happens if you add an area and a piece of string? You get an area and a piece of string, right? That's all you get. Okay, so you can't do anything with that anymore. It's just 3x squared plus 5x. So I can't simplify the addition.
But if it was 3x squared plus 5x squared, could you?
Yeah, if they were both x squareds, then they're alike. Or if they're both x's, then they're alike. You got it. Yeah, so I can't simplify the addition if they're not like. Okay, so you had a homework problem that might have looked something like this. Oops. 3x squared plus 5x plus 7x. Now here I say, okay, are any of these alike? And I can go, well, yeah, these guys here are alike, but that one's just different. So the 3x squared is stuck all alone. But if I have 5x's and 7x's all together, I must have how many x's? 12 on a good day. Yeah, so that one simplifies there.
And you don't add the x's?
No, because again, these guys are not like. This is an area, this is a piece of string, and since they're not like, I can't simplify it anymore.
But even the 5x plus the 7x, that's not going to be...
Well, these guys are like, yeah, so 5x's and 7x's, 5 and 7 gives me the 12.
Right, but it's not going to be x squared.
Nope. No, because think of the x as an object. Okay, so maybe it's a piece of string. So you have 5 pieces of string and 7 pieces of string. How many pieces of string do you have altogether? You have 12 of them. You don't have 12 squared strings. You still have just 12 pieces of string.
What if you were multiplying 5x and 7x? Then
okay, that's multiplying's a whole different story. And that's where we had to do like conversions, like square feet to square inches and things like that. That's more complicated. Okay, but as far as adding and subtracting things like this go, they have to have the same variable to the same power. So here's another example. So suppose I had a variable called L and another variable called W. And literally, they can be the length and width of a rectangle. If I want to calculate the perimeter, I got to keep working my way around. There's another length up here, and there's another width over there. All right, so would you agree, according to this picture, the length and the width are two different things, even though they're both measurements?
Yeah.
So what I could say is, how many lengths do I have up here? I have 2 lengths. And how many widths do I have? I have 2 of them. So this is another example of adding like terms. Things are like if they're the same variable and they have the same power. If they don't have a power, that's like having a power of 1. Okay, so they're all alike. So perimeter formula can either be written that way, or it can be written this way. I can't simplify it anymore because L and W are not the same variable, so they are not like at that point. Okay, so that's another example of where like terms come together in the perimeter formula for a rectangle. All right, we'll get to the example you're asking about in just 1 second. Yeah. All right, so another thing, so Emily asked, well, okay, so that's adding them, but what about happens when you multiply them together? So let's take, for example, a 2x squared times a 3x. So parentheses next to each other without a symbol implies it's multiplication, right? 2 next to the x squared is a multiplication. Well, I meant that to be an x, sorry. There we go. 3 next to the x is really 3 times x, right? So think about the order of operations. Parentheses, exponents, multiplication, division, addition, subtraction. Multiplication and addition are supposed to be done together from the left to the right as you read them. However, we know some other tricks. What's the difference between 2 times 3 and 3 times 2? There's no difference. It doesn't matter what order we multiply in, right? So up here, what I really have is just a whole bunch of multiplications. 2 times x squared times 3 times x. Doesn't matter what order I multiply those guys in. No, it doesn't, because 2 times 3 is 3 times 2. I can multiply in any order I want. So I could choose to rewrite this. I could say, well, let's write the 2 times 3 together, because I know that. That's easy. And then let's write the x squared by the x, like that. Still the same problem. Now I just break it down. 2 times 3 is what? 6. And here's the tricky part. What happens if I multiply x squared by an x? I add the powers. Yeah. So another way to think about this, x squared is an area, like the floor. X would be the height of the room. How do we measure the volume of a room? In like cubic feet, right? Or cubic inches or cubic meters. So this is going to be x cubed. Now, x, let me write this in red over here, x is the same thing as x to the first power. Because remember, what does it mean to be an exponent? The exponent tells you how many times to write the base, and then you multiply, right? So there's 1x here, there's 2 x's there, they're all being multiplied, so altogether I have 3 x's. So if you're multiplying 2 things like this, you just multiply the regular numbers together, put the variables together. If they're the same base, you get to add the powers. That was a rule we played with a couple weeks ago. Okay, so I have to view them, they're all multiplied together. So again, in my head, I just kind of separate them out. You can write those steps if it makes you feel better. But the whole numbers get dealt with, the variables get dealt with. Okay. All right, so those I noticed were kind of a pain in the butt, tough problems on the prep. Were there some other ones? Let's bring that prep up here now. Prep 1.7, right? Am I in the right side? Oh, no, are we on? Yeah, prep 1.7. Okay, so this just talks about square feet. You should read that if you haven't. All right. So that one wasn't too bad. We kind of just talked about that. All right. Ooh, let's review D. We didn't talk about that one today at least. So we did problem kind of like D a while ago. So let's write that down in the notebook here. Those numbers again. 4, 2, and 3. So the way I can handle this right there is an 8/2 times an x to the 4th over x cubed. So I think we did one of these in class before, but I'm not positive. Think about how you multiply fractions. You multiply the numerators, you multiply the denominators. So here what I'm doing is basically unmultiplying those fractions. Okay? So then I can just think about them in pieces. What is 8/2? 4. That's 4. And then here, this says there's 4 x's multiplied in the top. This says there's 3 x's in the bottom. Are there more in the top or bottom? Top, how many more are in the top? 1 more, so that means I get x to the 1st power, which you could just say is 4x. So that's kind of the intuitive way to think about it. The rule we had for this was that if you had a division with the same base, then you keep the base and subtract the powers. Remember we did that a while ago? I think it was like activity 2. 4 minus 3 gives me the 1 that I see here. So that's the other way to think about it in terms of a formula. So 4x ought to be the answer for that one. Question on that one? Not too bad? All right, let's see what else was interesting in here. 3, that was the like term stuff. Let's take a look at D. And we'll grab a screenshot of that. All right, so you write down what you think that simplifies to using the idea of like terms. I'll write down my version, see if we agree. All right, so I see 2 different kinds of things up here. I see things with x's and things without. So the things with x's, since they're both x to the 1st power, they're like. So I have 2 x's and 3 x's. So altogether, how many x's do I have? 5. 5. And then here we lost 5, but then we gained 1. So yeah, we get a minus 4. So that negative is attached to the 5. In algebra, subtracting is adding the opposite. So when I see something like this up here, in my head, I'm thinking that's a 2x plus a minus 5 plus a 3x plus a 1. Order of operations says you ought to add left to right, but these guys aren't like. But I know I can add in any order I want, right? 2 plus 3, 3 plus 2, same thing. So I can rewrite this as 2x plus 3x plus minus 5 plus 1. Remembering, right, that negative is stuck with the 5. So here again is my 5x. Think about x's as an object, a box, a piece of string, right? But they are the same object. And here I lost 5 and gained 1, so I'm down 4 in the end. Okay. All right, I think there was at least one more interesting problem, then we'll go to the worksheets. That one's not too bad. That one is a good one. Okay, so here we're just playing around with area. So I think I will steal these into my worksheet, and then we'll play with the lesson. All right, so it says find the unknown quantity in each situation. Whenever I have something like this, I like to draw a picture of it. Help me figure it out. I recommend you do the same. So we got a rectangle with an area of 72 square inches. Now, something I need to remember to do this, area of a rectangle, that's just length times width. Okay. So I have some rectangle. I don't know if it's long and skinny or short and fat or what, or square-like, so I'm just going to draw that. And the inside is 72 square inches. So I'll put that here. Let's see. And it has a length of 6 inches. So I'm going to put the 6 inches over there. So they want to know, what must the height be? Okay, well, this is apparently my height right here. What can I do to figure that out? Yeah, it's going to be a division. So if I knew the height, I would just multiply to get 72. Since I don't know the height, I have to divide. You can kind of think about that with a little algebra. If I fill in this formula right here, the area is 72. That's equal to the 6 times my missing height. So to break that multiplication, I divide both sides by 6. 6 divided by 6 is 1. 1 times 8 is h. So h has to be whatever 72 divided by 6 is. And on a good day, that's what, 12 maybe? Sound good? So it appears that this sucker's 12 inches in height.
Why is the height at the bottom?
Why not?
It throws me off, like heights.
So anytime I first start drawing a picture, everything's unknown to me. So I mentioned when I started drawing it, I don't know if this thing is short and fat or tall and skinny. Okay. And it wasn't until after I kind of calculated the height that I say, oh, it should have been tall and skinny. So just tilt your head sideways, and then you got it. Yeah, so anytime you solve a problem, it's messy at first. If that freaks you out, then redraw it on another piece of paper to scale. Okay. And some days that freaks me out and I redraw it. I hear you. All right, let's skip down to C. I'll leave B for fun for you. A rectangle with an area of 1 square foot. Oops, that's not a pen. 1 square foot has a height of 6 inches. What is the length? Okay. So let's see, new page. So I have a rectangle. I have no idea whether it's tall and skinny or short and fat, so Emily, bear with me if I don't draw it to scale here. So let's say that's my rectangle. They said the area is 1 foot squared or 1 square foot. And they told me one of the measurements, which one? The height is 6, okay. So the height is 6 inches. I need to know what this width or length, whatever you want to call it down here is. I have a problem I have to deal with before I can continue. What's the problem?
To change.
Yeah, the units don't match. I either got to change inches to feet or feet to inches. Okay. What do they want the answer in? They want the answer in inches, so it looks like I'm changing feet to inches. Okay. How many inches are in a foot?
12.
Yeah. So there are 12 inches in 1 foot. Now I need to deal with square feet. So that means I have to square both sides here. So 12 squared?
144.
Yeah, so there are 144 square inches in 1 square foot. And you can either abbreviate square foot like that, or you could write it as feet squared. It means the same thing. Okay. All right, so back here, 1 square foot must be the same area as 144 inches squared. So now I can deal with it. The area of 144 has to equal 6 times some missing number. How do I find the missing number?
Divide.
Yeah, divide by that 6. So the question mark has to be 144 over 6. I'm going to guess 24. Okay, lucky guess. So I would plug 24 into my box. The box already has the IN for inches, so I don't need to write IN for inches. I just type in my 24 and pray it's right. All right, so if you haven't finished the prep, get on there, get it done. If you have any other questions about it, let me know. Let's play with the worksheet. So, all right, so let's see, is this the right one? Okay, so we're playing around with the Mazurski's lot. And we had a couple of estimates in class that it was somewhere, using the figures here, it was somewhere between $200 and $300. He said $600. What's up with that, right? So we got to ask him to double check his numbers or find a new person to do the grass or do it ourselves. Does anybody have any questions about turning this into what his cost should be?
How did you figure out the 2 to 300?
Okay, let's do it. So I need two things here. I need a screenshot of the lawn area.
I did it and thought I was wrong. So
Yeah.
I did it a different way, but got the same answer.
Oh, awesome. You redid it and got the same answer. That's wicked cool.
I think.
Good job. Okay, so.
I was expecting him to be undercharging.
Yeah, it seems
So I
like,
was like,
yeah, so maybe his fees here are too low. Like he ought to charge more money.
I didn't think that it was that bad.
Okay, so this was an ad. Notice it says this is an advertisement he had. Okay, so to make this happen, we need a couple of things. We need the area of the backyard because he talks about square feet here. So we got to know how many square feet that is. So my recollection from last class is we measured this to be about 130 feet, and we measured this based on the scale here to be 115 feet. And we multiplied those two together. And then we also had this little extra area we didn't count over there. And this little chunk right there, I believe, was 550 feet squared.
Why is it just 50?
And all together, I think we got 15,500 square feet. Does that sound right for this area of the backyard?
There's
So
15,000.
15,500 square feet. What was that, Jenna?
I think it's just 15. I had 15,500.
Yeah, 15,500. Okay, so we can just double check by plugging that into Google. This is the whole area of the backyard? Okay,
So
so,
why is it 550 feet, not 50 feet?
okay, so good question. Why is this the bump out here 550? That will pop out. Each square here is 10 by 10. So the area of one square is 100 feet squared. 100 square feet. So there's 100, 200, 300, 400, 500, and that at the top is half a square. So half of 100 would be 50. So that's why I was calling it 550. With me?
Yeah, I was only counting by 10. So
Yeah, so careful. Counting by tens means you're doing length. If we're doing area, each square is 100. Yeah, so we got to be a little careful. A little carefuler? Is carefuler a word?
I just think about it, that's just a rectangle.
It's just a rectangle, yeah. So you could multiply 10 by 55, and that because it's 10 units wide. Yeah, so that's an excellent way of thinking about it. Yeah, so I'm just going to double check, plug it in here. So I have 130 feet times 115 feet plus, as Colt said, another spot that's 10 feet by 55 feet. Yeah, and there Google says, yep, that's 15,500 square feet of yard in the back that we have to deal with. Okay, so our next goal is we need to turn square feet into dollars, and this should help, these figures here should help us do that. So let's switch color. So I'm just going to pick on, say, this top one right here. Right at the moment, I have 15,500 feet squared. I need to multiply that by a conversion fraction that's going to get rid of the feet squared. And right here, they tell me that for every 1,000 feet squared, I need 4 pounds of grass seed. So multiplying by that rate, because per is a fraction, right? Per means divide. Writing that as a fraction allows me to cancel out the feet squared and change it to pounds. Okay, what do I do to get rid of pounds? Yeah, the 125 is dollars per pound. So literally dollars per pound, which cancels out the pounds there. So he says every 1 pound is $1.25. So this will get rid of square feet it'll get rid of pounds, and the only unit I didn't cross out is dollars, which is what I want. So to do this, I would take my 15,500, multiply by 4, divide by 1,000, and then multiply by the 1.25. There'll be a similar calculation for fertilizer, and then the labor calculation is just a straight multiplication. So double check those later. I remember numbers somewhere between 200 and 300. Oh, did I write my numbers down? You got 280? Okay. You got 289. I did not write mine down. Nope. But I have a spreadsheet I can show you.
But I did my notes.
Yeah, there's always, for complicated problems, there's always more than one way to do it.
Figured out.
Let's see, where.
1 pound is 250.
Yeah, so you could get a per pound rate, totally. Yeah, we talked about unit rates before. Yep, that's a good way to do it too. So let's see, yard for less than 1.7, maybe this one. Nope, that's just a picture of the yard. Oh, I need a spreadsheet here, maybe. Here we go, less than 1.7 worksheet. Okay, so here's my spreadsheet when I was playing around with this. So I mentioned before, anytime I make a spreadsheet, I put notes about what I'm talking about all over the place. So here's a note. This is about the Murkowski's drawing, or Mazurski's. I don't know why I can't get that right. I made a note to myself for scale. 1 unit on the drawing is 10 feet in reality, or 1 whole square is 100 square feet. Okay, because I found I was occasionally confusing those like you, and I got wrong numbers. Like it should have been 5,000. I was saying 500 because I was mixing my units. So I had to remind myself. As far as the grass seed goes, I kind of did what you did. I did a pounds per square foot calculation here. And I found like for the grass seed, it was less than a cent per square foot. And then I could multiply by the cost to get a value on that. So altogether, I found the grass seed was about $77.50.
Yeah, I said 7.5.
Okay, same thing, yep. And then with the fertilizer, almost the same calculation, slightly different numbers. So here I have 50 over 1,200 instead of 4 over 1,000, but same idea. And I got that the fertilizer was $32.29, and $45 an hour for 4 hours was $180, and mine added up to $290. You got the $290 this when you redid it, okay. And yeah, I'm not showing decimals there, so I bet if I show decimals, it'll probably look a little different.
Yeah, that's what I saw.
Yeah, so I got 289.79. So, and again, if we round at different stages, our answers are going to be slightly different, but we better be in the ballpark, right? So clearly, Jerry, I think that's his name, he messed up a power of 10 somewhere, right? His answer is twice as big as it should be. So he's got a serious calculation error, or he just wants more money. We don't know. Yeah, well, according to what he advertised, it ain't, right? It should be half that price. The fence seems expensive. All right. So so double check your numbers, and then we can talk about this some more tomorrow if you want. Let's take a look at the next couple of parts because we're running out of time. Let's see, where did I go? So to do the fence, I need this picture again because I'm gonna have to draw on it.
I know they probably do that, but I wasn't sure to pop out.
Yeah, so basically I just drew all over my picture to figure that out. Okay, so things we need to know. Let me get some more information from the worksheet. Not that. Where's my other, oh, there you are. Stick you in here in case we need you again. All right, so we're jumping over to the fence problem. So some things that we're gonna have to include eventually. We're building a chain link fence around the backyard. The fence is going to have 2 gates on either side of the house. They're going to do the work themselves. They just need to buy all the equipment and or supplies, and there's going to be a 9.4% sales tax. We'll have to calculate that in at some point. So these are the prices that we need right there for the calculation. So screenshot that. Come on. There you go. Screenshots. All right, So we need to know this right here. I guess I'll stick it there. So other things to consider, and you guys are gonna have to play around with this. They need an inline post at least every 8 feet. So there can't be a distance of more than 8 feet between posts, is the bottom line there. So we're gonna have to figure that part out. So the first thing I did here is I started just thinking about corner posts and lengths. So first I'm gonna just draw on this where I think the fence goes. So let's draw that.
The fence is already drawn.
It is and it isn't. So I need to draw more to feel comfortable about
Okay,
this.
that's what I-
So there's gonna be fence from that post right there down from this corner to that corner, to this corner to that corner, to this corner to that corner, and then from that corner to that post. So that's the fence. The gates don't count as fence, they're gates, okay? So they're not in there. And I think they give me the width of a gate somewhere, 48 inches, okay. So problem, I'm dealing with feet, that's in inches, so I need to convert 48 inches to feet, which is pretty easy. It's what? 4 feet? Okay. So as far as the fence line goes, although the distance from the edge to the house here is 25 feet, 4 feet of it is taken up by the gate. So really I only have 21 feet on that side, okay? Is it a big deal to get 4 extra feet of fence? Not really, but you gotta pay for it, and then what are you gonna do with it after? Still let it sit in your backyard, collecting dust? So we wanna buy just enough fence, but not too much. All right, so there's where I need fence. So the next thing I went around marking is where I need corner posts. Well, there's a corner there, right? And a corner here, corner there, corner there.
And we
And
get
you need one at each
Yeah,
gate.
we need a corner post where each gate's gonna be
2 for each gate.
2 at each gate.
2 at each gate, because I'm not gonna attach the gate to the house. That would be bad form. Yeah, so there's gonna be 1 there and 1 there.
That'd be some hillbilly stuff.
20 times.
Yeah.
About 6.
All right, so it looks like I need 1, 2, 3, 4, 5, 6, 7, 8. So I'm gonna make a note in here. So where are my corner posts? I need 8 of those suckers. I know I need 2 gates, and the gates take up 4 feet. So I'm gonna make a note of that. Oh, and the chain link, so linear just length, yard is 3 feet. So I'm just gonna make a note to myself, a yard is 3 feet. So every 3 feet, they charge me $21 for the fence.
But didn't you have to figure out the limit? 'Cause
Yeah, we're gonna get there. So I'm just kind of, going over all the facts that I need. All right, so then we start playing with the perimeter. So I know the distance from here to here is 130. We calculated that earlier. We calculated this to be, what, 115? And I should make a note of the units, feet. Because we have inches here, we have feet, and we have yards. We're gonna keep our units straight. What's the top length?
the 130.
140, right? Because the house has that little pop out, so it's different on the top versus the bottom. So it's 140 up here because of the shape of the house. How much fence do I need at the top part of the house? Let's say that's the north part. This little piece up here?
25.
Almost, not 25. 25 is the difference from the edge of the yard to the house, but what's sitting in there between? A gate. Yeah, we don't want to cover the gate with fence, right? So how many feet do we really need?
15.
What's the distance from the edge of the house to the edge of the property? It's 25. How big is a gate?
48 inches.
A gate is 4 feet, so we need, everything's average, it's 21 feet. 25 minus the 4 foot for the gate leaves us 21 feet of fencing needed up there. How much fencing do I need in the southern part here? That's what, 10, 20, 30, 40 feet to the house, but there's a gate. 36 feet of fence there. Yeah. So now what you got to think about is if you can go no more than 8 feet, how many posts do you need for each side? You could add the whole perimeter up and then divide by 8.
That wouldn't work out correct.
Okay, why won't that work out correctly?
Because the short sides needs posts.
Yeah,
That would
you're
come
going to
out
have
correct.
fractions of 8 on each side,
Yeah.
right? So I think if we add everything up and divide by 8, we'll get a different number than if we do each side one at a time. Okay. So personal experience, I've made that mistake before, and I had to go run back to Home Depot and get some more stuff, right? Because I thought it'd be quicker to add them all up. Oops, right? Learn from experience. All right. So everybody give that an estimate, see how many posts you come up with. We get just a few more minutes to play together. If you already got one, you already got an estimate?
Yeah, 56.
Do you think we need 56 posts? Okay.
So you would do each side and then you would add your posts?
That's what I would do. I would do each side individually and then add them up how many posts you need. Yeah. Okay. So Robert has an estimate of 56 posts. Now, usually it's a good idea to buy a little extra in case something goes wrong, but we don't want to buy too much extra because that costs us money. And then we have to take them back, or they take up space and wherever we're working. So we don't want too little, we don't want too much. You do need the total perimeter for the fence, correct? Absolutely, yeah. But as far as calculating the posts, we're safer to just do each side one at a time. So whip out those calculators, get some numbers there if you haven't calculated them already. Your calculator?
No.
You guys don't have the printouts. You gotta speak up. Just sit there quiet. They all are on the website. If you ever want to print them out ahead of time.
Thank you. Since you want to have, you got it to mix, so if you do that up, right?
You would have to round up. Yeah, so that's a good question. So let me do one of these for an example. Let's take, so 115 divided by 8 gives me 14.375. So what does that mean? That means 14 groups of 8 plus some extra. So what is that going to look like? So I'm going to draw that out just for fun and see what I do with that number. So I just took that length of 115, and the red's going to be my corner post, and so then I have the other post to put in there. And so it came out to 14. So 1, 2, 3, 4, 5, 6, 7. I hope I'm spacing them right. 8, 9, 10, 11, 12, 13, 14. So double check. Somebody with a calculator. What is 14 times 8? Because my drawing is not to scale.
112.
It's 112. So to get from here to here with my 14 posts, I've covered 112 feet. I need to cover how much?
115.
115. And so that means this remaining area is how much? 3 feet? Okay. Is that okay to leave 3 feet from an inline post to a corner post? It is okay. Because it said you can't have more than 8 feet. And so again, when I counted these out, I just write those numbers down. Color, there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's the 14th post right there. Given I started with a corner post, every new post gives me another 8 feet. So 8 times 14 is 112. And then that 0.375 ends up being 3 feet, 3 out of 8 feet. And so that remaining 3 feet is okay, hanging out there. Could I not have that 14th post? If I skip the 14th post, then I would have 8 feet plus 3 feet, which would be what, 11 feet? That's too far to span. The fence can't handle that. That'll be weakened. Yeah, so it turns out I actually only need 14 posts on that side. Why? Because I already have corner posts in place. If I didn't have the corner posts in place, then like Emily said, I'd have to round up to get one more post to the corner. But we already have the corner posts. Okay, hopefully that helps.
I need, wondering, I had a question about this.
Yeah, we're gonna take a look at that one next. Actually, we're gonna pause right here. If you're not finished with that calculation, tough, sorry. We can look at it again tomorrow. We need to take a look at, because we only have a few minutes left.
I don't get the 2-inch thick part where you.
Yeah, okay. What's that?
For that one, don't you have to have like reactions?
Yeah, okay, so for the formula here, so let's see. We need to build a semicircular grill. So a semicircular patio. So just the shaded part is the patio. And they're telling me that this is 3 by 6. So that must be what, something that's already existing?
3 times 5.
Yeah, so as far as formulas, we need to calculate that. Page. The area of the circle is pi times the radius squared. Now that's a full circle, and the radius is the distance from the center to the edge. We want half of that. We have a semicircle. So that would be pi times the radius squared, which is divided by 2 after. No big deal. Thinking about our semicircle, if I do some shading here, we have just this right here. So what are the dimensions of this semicircle? I need the radius. What's the radius of my semicircle? According to that picture we were just looking at.
3.
That's 3. The diameter was 6. So let me bring that back up. The diameter, which is all the way across through the middle, that's 6. Half of that is the radius. And notice that if I go from this center point up to the top, that's 1, 2, 3 units. So the radius is definitely 3 here, not 6. All right. Now, that's in feet. So here, again, this is an area. My area is going to be pi. Pi is about 3.14 times the radius, 3, squared, and then divide that by 2. So that's going to give us some number. Area, that's like paint over the top. What am I actually doing here? I'm pouring concrete. How thick was the concrete again, Robert? 2 inches?
2 inches.
Well, that's thin. That's not going to last long. I would do 4.
Yeah, so 4.
Okay, so we're going to do what they say. They want 2, fine. They can have a 2-inch thick patio. It's going to crack very soon. So what's the problem with our numbers here? Well, what's our area measured in? Feet squared, because it's area. But they gave me a thickness in inches. So guess what I got to do? I need to convert those inches to feet. So to get the volume of concrete, volume is area times height or thickness. My area is whatever that pi times 3 squared divided by 2 comes out to be. The height, however, I have to change to feet. How many inches in a foot? 12. So that means my height is 2/12 of a foot. So this is going to give me square feet times feet, which in the end is going to give me an answer in cubic feet.
That's 1/6, right?
Which is going to be 1/6, yeah, if you wanted to simplify it. Right, and we don't need to worry about simplifying it here because we're throwing pi into the mix, which means we have to round no matter what. All right, play with that some more tonight. We'll finish this up in class tomorrow and start lesson 8 also. So we'll finish going over the fence problem in class tomorrow, and we'll finish going over the concrete. Do your best to tidy it up, and I will see you all tomorrow. Daisy, you got any questions?